Hello class, I'll be performing experiment 10 today with the calculations portion that follows the previous experiment that we did from experiment 9 of the titration setup. So before that was the titration setup, today we're doing the calculations portion. So first off, I'm going to show you how to calculate the volume of the titrant added. So first off, we just take the final burette reading, which was 24 milliliters, and subtract it from the initial burette reading, which was 0. And that's what gives us 24 milliliters. Okay, easy. So now we're going to show you how to calculate the moles now of the sodium hydroxide. So here we have 0.024. The way we got that was by just taking the 24 milliliters of the titrant and then converting it to liters. And that's how we got 0.024 liters of sodium hydroxide. And then we're going to multiply by 1.107 moles of sodium hydroxide. The 0.107 is from our last answer that we got from experiment 9, by the way. So 0.107 divided by 1 liter of sodium hydroxide. And notice that the liters get canceled out. So what we're left with is moles of sodium hydroxide. And that's what we get for the answer. 0.003 moles of sodium hydroxide. Now, to calculate the moles of hydrochloric acid, what we did was take the 0.024 liters. Remember, that was from the 24 milliliters. We just converted it to liters like how we already did. We just plugged it in down here, multiplied it by 0.107 moles of sodium hydroxide divided by the 1 liter of sodium hydroxide. Then we multiply it by the 1-to-1 mole ratio. And the 1-to-1 mole ratio is just the equal number of moles at the stoichiometric equivalence point. So because those two are 1-to-1, they should have the moles of the sodium hydroxide and the moles of hydrochloric acid should be the same. So we're going to do the math. So we did the math and we got 0.003 moles of hydrochloric acid. Okay. Now we're going to try to I'm going to show you how to calculate the final molarity or the concentration of the hydrochloric acid now. So I plugged in everything here and we did the 0.024 liters, remember from the 24 milliliters of sodium hydroxide. We multiply it by 0.107 moles of sodium hydroxide divided by the 1 liter. Then you multiply it by the 1-to-1 mole ratio of hydrochloric acid to sodium hydroxide, and then we multiply 1 over 0.025 liters of hydrochloric acid. And where we get this from is we get it from the given. They gave us that, which was 24 milliliters. All we did was just convert it to liters here. And our answer that we got here for the final molarity or the final concentration is 0.12 molar of hydrochloric acid. Okay, so basically how I summed that up, I just got the moles of hydrochloric acid, which is this 0.003, and then divided it by the volume. So you can just do the moles divided by the volume and got 0.025 liters, and then that's how we got the 0.12. But we just did the math out to show you how we understood it. Now to find the average, now we just did the 3 trials. And we should have gotten the same number if we did it precisely. And we, the numbers that we got are from the final molarity or concentration, which is 0.12 plus 0.12 plus 0.12. And when we add, divided by 3. So to get the average now, all you have to do is add up the 3 trials that you did, and which gives us the 3 trials that we did, which gives us 0.36. And then we divide that by 3, which is going to give us what we started off with at first, which was 0.12. Anytime we do that and then divide it by the same amount of numbers, we're going to get the same number that we started off with if we did the equation correctly. But we did the math out, and here we got 0.12 moles per liter.